I'm going to give a brief introduction about why synonym expansion is important in search engines like using Solr, Elasticsearch, and so on. We mostly highlight Lucene and Solr. We briefly introduce Word2Vec. Then we see what was the purpose of our contribution. We will see some examples, and we will tell you the story of the contribution, because we took about 1.5 years to get it done, and we want to see what happened, why it happened, and what do we learn from that. And finally, we will see some future works we are planning to do. So let's get started. Okay, why synonyms are important? So we want to improve recall. Recall is the number of relevant documents that are retrieved over the total number of relevant documents. So if we are querying, okay, for example, best places for our work, I also want to retrieve documents that contains hiking or trekking, because maybe they are relevant. So how is it implemented in Lucene? We have a static file that we pass to an analyzer. So we create our custom analyzer. We create a synonym graph filter, and we pass this static file that contains synonym to that filter. So the static file is something like that. I don't know, you see a list of synonyms. For example, if you see the first line, couch and sofa are synonyms. So Lucene supports 2 different types of files. We have this static file that's that format, and we have the WordNet file. So what are the limits? We have, so we don't care about the domain where that specific word is used to. If we have different languages, we have to generate and we have to find synonym file for each language. And then for some languages, it's not easy. If we want to update something, it requires manual maintenance that for a company, mostly it brings to additional cost. And these synonyms are based on the denotation of the term, not its connotation. Just to give you an example, I remember when I was studying, I was reading a book about operating system, and they found, it was written in Italian, maybe translated to Italian, and they found this word, this sentence, there was a devil that triggered this task. Wait a moment. That was clearly a wrong translation of a daemon. So because daemon in operating system is not a devil, is a process. So that's why actually the domain is important. So just a couple of words about Word2Vec. So Word2Vec is a neural network. So Word2Vec gets, so is a network that can read and can parse a lot of sentences, and it can generate for each it can create a dictionary of it can associate for each term a vector. So the idea behind Word2Vec is that multiple terms with synonyms with closer meaning, so synonym term, are mostly used in a similar context. So if I say I like pizza, I love pizza, like and love are synonyms. I can also say I hate pizza or I eat pizza. So hate and love are not synonyms. So actually that's why it's extremely important to send to the Word2Vec network a lot of sentences, so that the network can find other examples where, I don't know, hate is used in a different context, and it can figure out that hate is not a synonym of like. For using Word2Vec, we didn't implement the network. For our test and our purposes, we use the Deep Learning for J library. This is an open source library. It's written in Java and Scala as well. We can integrate it with Hadoop, Spark, and there is a good community. So we decided to use it. if you train a model using Word2Vec, you can export that Word2Vec model in a zip file. That file contains another file, scene0.txt, that has that format. We have a list of terms encoded in base 64, and afterwards there is the vector associated to that term. So this vector is structured to be, if we have terms with closer meaning, also the vectors are closer to each other. So they have a high cosine similarity between them. Okay, in this example, the dimension is just to show it in that page. But we normally use higher dimensions. So let's see what we did. We implemented another synonym filter called Word2Vec synonym filter that's similar to the one we have, but instead of getting the static file, it gets the model. So we had to solve three problems. We need to parse the model, store it, and query the model to implement the synonym expansion. So as a first, our first idea was, okay, we have the library, the Learning4j, it does everything, fine. But we try to do some tests. First of all, each synonym expansion was pretty slow because it takes about 70 milliseconds. I did this test on my laptop. Maybe on a server can be a bit faster, but not so much. And then when we try to import all these, so the deep Learning4j library into Lucene, this library brings with it a lot of dependencies. So I remember I had to stay a couple of days importing, exporting, import and exclude all the dependencies. And it became a mess. So we did a step back. So what do we want? Actually, for the synonym expansion, we start from a word. We get the vector associated to that word, get it from the model. If we put the vector in the vector space of all the vectors generated by the model, we need to select the closest vectors and then the relative words that are supposed to be synonyms. But this is the K-NN search. It's nothing more. So the K-NN search is already implemented in Lucene using the HNSW graph algorithm. Just a few words. So the hierarchical navigable ball word graph is a kind of recent algorithm. It's a data structure that is a kind of mix between skip list and proximity graph. So if you think about a skip list, what you have, you have the lower layer with all your nodes. And then if you go up in layers, you see that some node is missing. That allows you to do a bigger jump and skip it a lot of nodes. So instead of having a list of elements, you have a proximity graph. So you have a multiple layer of proximity graphs. On the lower layer, you have all your nodes, all your vectors. And going upper, you have a subset of the vectors. The idea is that you start from the top level, you find the closest vector to your target, and then you refine the search going down. So upper the layer is, longer the jump is, then going down, you have a more accurate search. And this is an approximate algorithm. It's much faster than the Excel search, but even if it's approximate, it gives you a very good approximation. So what we did, our problems. So for model parsing, we implement a parser for that scene0 file that we seen before. For model storing, we use the class already implemented in Lucene, that is the HNSW graph. And for synonym expansion, we use a graph searcher, HNSW graph searcher implemented in Lucene that allows you to navigate into the HNSW graph. We found a speed up of about 1 order of magnitude, and we didn't need any additional dependencies. So it makes this Lucene source code much simpler and smaller. So I mean, we didn't increase the size. So we have this Word2Vec synonym filter that gets some parameters. The model, the zip file of the model generated by deep learning 4J. Okay, we also ask the format. At the moment, we only support deep learning 4J, but nobody. So I mean, nobody's. I mean, if you want to implement another model that based on BERT, for example, you can do it. You can do another contribution that support BERT, and you, of course, you can also add another parameter here. You want to see how many synonyms per term you want to get. The default is 5, but you can change it. What is the minimal upset similarity? Because we have vectors, we want to put a threshold to say, okay, over more than 2 similarities, the term must be considered synonyms, after no. And we have the similarity as a boost. So if we consider the cosine similarity between 2 vectors as a boost for the term. So closer vectors means more synonym terms, so higher boost. That's the idea. We also did another contribution, but this is not part of Lucene. This is publicly available on our Sease repository. And this is the Lucene Word2Vec model trainer, because we said one of the problems of the static file is that we don't take into consideration the domain, our domain. So we created a trainer to train the model starting from our data. So we get, okay, this is a command line tool, first of all. We get 3 inputs at the moment. We want to expand it in the future, but at the moment we get the path of the Lucene index. We want the field name, and we want the file of the output model. So starting from your own model, you can generate, starting from your own data, you can generate the model, and then you can use that model for synonym expansion. So that's the best way to have your something, I mean, appropriate for you. Let's quickly see some examples. Just how do we use it? We want to get synonyms in Italian. We didn't have it. We generate it. We download all the Wikipedia pages in Italian. There were about 3.4 gigabytes of data, 1.1 million, no, almost 2 million documents. We store them on a Lucene index, and then we run our model trainer. So we run the trainer. We pass the path of the Lucene index. Okay, no fantasy. The field name was text, and then we generated our model, Wikipedia model.zip. We start processing, and after, okay, in that specific example, after 163 minutes, we got the model. We need to be aware that at the moment, for training the model, we just use the default parameters of deep learning 4J. We want to allow people to add custom parameters so they can do a better tuning. But at the moment, we are more interested in having synonym expansion. So we created also another mode testing code. We create a custom analyzer. We pass our synonym filter factory, and we pass the as a model the Wikipedia model.zip, the file generated before. We open our Lucene directory, and we start searching. Okay, we ask the user to print a word, and we generate the query and we print it. As a test, we add computer. Is a part now of the Italian vocabulary, but everybody here can understand. We got some synonyms: microprocessor, controller, microcomputer, desktop, notebook, hardware, software, chip, mainframe. Some of them are correct, some of them no. But as I said, we didn't do any tuning to train when we train the model. And what is more important is that when we generated the query, we can see the query with all expanded with all synonyms, and we apply a boost that is the similarity. We also did the same test at index time. If you want to do something similar, you have to be aware that this impact on the index size if we span synonyms at index time. So the indexer it's gonna be slower. And if you change something in your model, you have to reindex everything. By the way, apart that, we did our test. We used the same analyzer. We created an empty, a new actually index, Lucene index, and we had only one document with only one field with only one word, computer. We commit this document and we open it using Luke just to see what is stored on the Lucene index, and we saw that 10 words we've seen before. This is important because we want to see that the synonym expansion works also at index time. So a few considerations. When we create everything, to build the graph, we took about 2 minutes for that specific time. Maybe we can improve it. And we have some ideas in the related work. And something also for, we can see some words that are not synonyms. And this is why we didn't use we just used the default parameter for training. Let's see what happened. So we started thinking and designing our contribution last year in January. After 2 months, we had the first draft ready. I mean, we had a working version. And after we presented a Berlin Buzzword last year, saying we are going to publish a PR soon, because we only need, some refinement of the code, some, you need, some comments or documentation, or maybe clean up some code. But we published the PR this year in January. We will see what happened. Finally, we did manage to merge it in April, so a couple of months ago, 3 months ago. Afterwards, a guy found a bug, and to fix it, we take another 2 months. And everything was done, finished 3 weeks ago, I guess. So the first part I color is gray because, 2 months to study the theory, design, then change the design because we passed from the approach with the planning4j library to HNSW. Then we implement the version. 2 months are fine. Then no. So let's see. We are a consulting company. There was, in that 2 months, we didn't have, we were kind of free with customers. And afterwards, customer came. So our priority was not on this contribution, was on customers. So we didn't have a lot of time to dedicate to the contributions. I don't know, kind of 1 day per month. So every time you download the code, you check out the code, you merge everything, and you find a lot of conflicts, and you spend your own day to merge and resolve conflicts. So we fix everything, then the next month, same problem. So we spent too much time, and then we were also unlucky because looks like that year everybody was working on the HNSW graph. It happens. But what do we learn here? For the next time, before starting such a big contribution, because maybe we underevaluate how long it would take. So next time we should find other sponsor. Because at the moment we are the only company sponsoring this contribution. Maybe next time we need to find other people, maybe, or other companies to write the code, or maybe to finance part of some or part of the contribution. That's something for the future we need to keep in mind. We published the PR, and we had a few people pushing comments, adding comments. Some of them were reasonable, like, you need to refactor this one, or maybe this problem that you wrote the code to solve this problem, but this is already implemented. Perfectly fine, thanks. Some of the comments were not so useful, and there were some guys that didn't detail and didn't tell us why they require some changes. So this brings up to a long conversation, back and forth, and then all this conversation is offline. It's not just that you have a chat of 1 minute. And it takes other days over days. And we spend about 2 months to clarify what do we need, what do we need to do. But actually, after a while, we said, okay, the piece of the code so that there was where there was the complaint was of the functionality similarity as a boost. And if we keep talking and discussing, we come back to the original problem that everything changed and we need to spend days to merge the code and so on. So we temporarily remove the functionality at all. And we manage to merge the PR. So some consideration here. So the community is not just a company where people talk to each other, and maybe if there's something, we can schedule a meeting and discuss and understand what to do. The community, there are people with different backgrounds, different skills, different knowledge about Lucene in this case. Maybe there are people that, I don't know, expert, like for Alessandro, for example, or maybe there are people that is the first contribution, like me. So you need to be, when you ask something to do, some changes and so on, you should be patient and describe what is the problem, what's going to happen if you stay in that way, and detail everything. This is also a way for younger people, and is a way to learn from people who has more experience. By the way, we merged it. We managed to merge it. And then another reviewer, actually, he became a reviewer. This guy looked at the code and he realized that the HNSW graph searcher, do you remember that class that was used to navigate the HNSW graph and querying it? The class that we used was not trace safe. Okay, so we didn't have time. And we implement for that moment a quick mitigation. We know it's not a perfect solution, but this is a new tool. Even if it's not perfect, it's a bit slower, fine. It doesn't impact current customers, current users. But if people can start experimenting it, and maybe if more people, the community is more interested in that, someone else or us can improve it in a second time. That's the idea. But there was someone disagreed. Another long discussion, another 2 months, 1 month allowed, I guess, for discussion. And finally, another guy one of the reviewer implemented the trace safe HNSW graph searcher. So we simply had to use his version, the new version, and everything was fine. So also for that case, what was our mistake? We start the contribution without maybe a proper budget, without sponsor. So we ran out of budget, we ran out of time, and we didn't have. So we had to do some, quick mitigation. Nothing, not the perfect one. And another point is that when we build something, so our idea of a community is that we try to build the wall all together. I put the first brick, someone else can put his brick, and all together we bring the wall. we cannot expect that a company, in this case, small as us, or maybe a single person, to create the best system ever. We start small, with a small things, and then we iterate over it to create to have the best as possible. By the way, afterwards the bug was fixed, and everything is running and is published in the on Lucene 9.7. Now we know that there are limitations of the current solution. First of all, the model that we are using, we store it in the HNSW graph that is an object in memory. So in case of disaster recovery, we have to rerun the process, and as we saw, in our example, it took about 2 minutes to recreate the HNSW graph. It can be a lot. And also if we have multiple processes, we have multiple models. Each process needs to load in memory their own model. So one of the idea to store it, to fix it, is that instead of using the HNSW graph in memory, we can store the Word2Vec model as an index. This index is stored on the disk. So in case of disaster recovery, we can just query an index that it already exists on the scene. If we have multiple instances, multiple processes, can all of them use the same index? We don't need to replicate that index many times. Then we have the similarity as a boost functionality. We need to bring it back because we remove it. And finally, we want to speed up the search of the HNSW graph, because the term we are looking for is not a random vector. This is one of the vectors that is already stored in the HNSW graph. So if we are able, we need to explore the internals, but if we are able to access directly that node, we can quickly get the list of neighbor, that is, so the list of synonyms. So we don't need every time to do this, to implement the search. But we will need to study. And actually, if someone is interested and want to help us, let us know.